ചോറ് Hi all. Session we are going to discuss the remaining topics of arithmetic sequence, and especially this is for class 10, either SCRT or NCERT, right? Okay, right. So in this session we will discuss how to obtain general expression for arithmetic sequence, right? So in this class, we will discuss how to obtain the general expression for arithmetic sequence and related problems, right? So we know I'm writing an arithmetic sequence. For example, 5, 10, 15, 20, 25, and so go on to infinity, right? And we know we have position, right? This is our first position, second position, third position, fourth position, fifth position, and so on. And the number in the first position is called as first term. That is denoted by T1, and number in the second position, that is denoted by T2. That's the second term. And we have third term, fourth term, fifth term, and so on, right? So position is an integer, that is 1, 2, 3, 4, 5, 6, and so on, right? And the number belongs to the first position is 5. T1 is equal to 5, we have T2 is equal to 10, and this is an arithmetic sequence. Here the common difference is D. So we have general expression or nth term, right? Nth term of an arithmetic sequence, that is a plus n minus 1 times d. So we can write nth term of an arithmetic sequence Tn, that is equal to a plus n minus 1 times d, right? Here n is the position and d is the common difference and a is the first term, right? And a general sequence, arithmetic sequence, we can write first term a, and our second term, that is a plus common difference, right? This is our second term, and our third term is a plus 2d, and fourth term a plus 3d. This goes on, right? So nth term is denoted by TL, and it is given by a plus n minus 1 times d. We know here a and d are real numbers. Now we can simplify this. So I can write nth term, that is equal to a plus n times d, that is n multiplied by d minus d. So we can write this is equal to a plus n d, n times d minus d, right? Here a is a real number, I already told, and d is also a real number. So we can write this is equal to a minus d. This is the difference of two real numbers plus n. N is a position multiplied by common difference. Or so a minus d, this is again a real number. So we can denote this by some other alphabet by using capital letter A plus n times d is also a real number. So we can use another alphabet, maybe b. So we can write a plus NB, right? So a plus NB is the general term of an arithmetic sequence. Suppose we got a sequence, and if it is possible to generate the nth term, and if it is possible to express, it is in terms of a plus NB, that is a constant plus n times another constant, where a and b are real numbers. So general expression, right, for an arithmetic sequence, that is equal to some real number a plus n. N is the position. For first term n is equal to 1, for second term n is equal to 2, for third term n is equal to 3, and so on. So n times d, right? So this is a general expression for an arithmetic sequence where A, comma B belongs to real numbers, right? Real numbers. And N is an integer. N is an integer. This integer is called position, right? Position. For N is equal to 1, that implies first step. First step, right? First step. Okay. So N is equal to 2, that implies second step. And so on, right? Okay, so we can get from the general expression. Suppose we have general expression, then we can obtain all the terms of the sequence from this general expression, right? Suppose we develop the general expression. Now, want to find, suppose some 10th term. So what do we have to do? We just replace n by 10. So in this general expression, we can obtain first term, that is T1, that is equal to A plus n is equal to 1 for first term, 1 into B. That is equal to A plus B is the first term. And similarly, second term, T2 is equal to A plus for n, we have to put 2. So 2B, right? And T3, that is equal to A plus 3B, right? Okay, now we can obtain the common difference of an arithmetic sequence. There is a difference of any two consecutive terms. So I am calculating T2 minus T1, that is equal to T2 is our A plus 2B minus T1, that is A plus B. This A and it cancel. So this is equal to B. Right. We know B is a real number and this B is the common difference. Common difference. And we denote this as D. So this is D is equal to common difference. That is equal to D. Right. Okay. So if any expression is in the form a real number plus n times another real number, then that will definitely represent an arithmetic sequence, right? So we have developed the general expression so as to find or so as to analyze an arithmetic sequence, right? Okay, now based on this, we can do some problems, right? Suppose we have an arithmetic sequence 2, 4, 5, 2, 4, not 5, after 2, 4, we have a common difference too. So 6, 8, 10, this goes on, right? My question is to find or determine the general expression, that is general expression for the sequence given above. Okay, now looking at the sequence, we know this is an arithmetic sequence having first term A is equal to 2 and here common difference B is equal to 2, that is 4 minus 2, that is 2, or 6 minus 4, that is 2, or 8 minus 6, that is again 2, and so on. So as to obtain the general expression, first what we have to do, we have to write the expression for the nth term. We know that nth term, that is equal to A plus n minus 1 multiplied by D. Right. Now, substitute for A and D. We get this is equal to 2 plus n minus 1 times 2. Now, simplify this equation. We get this is equal to 2 plus 2 times n minus 2. Right. This 2 and 2 get cancelled. So, this is equal to 2n. Right. So, general expression is given as 2 times n. That means we can write general expression, right? For general expression or general term, right? That is equal to 2 times n for this sequence. Now, we can obtain various terms of the sequence by simply substituting the value of n. And we told n is the position. For first term, n is equal to 1. So we can write T1 is equal to 2 into 1. That is equal to 2. This is our first term, right? Now, for getting the second term, T2 is equal to 2 into n is equal to 2, that is equal to 4. You obtain the second term. And T3, that is equal to 2 times 3, that is equal to 6. We obtain the third term. So, first, we have to develop the general expression. And putting the value of n in the general expression, then we will get the corresponding terms. Right. Now, we can do another problem so as to find the general term. Right. Okay. Now, may I write the natural numbers? Right. Natural numbers. So, we can write natural numbers. Okay. What are the natural numbers? That is starting from 1, then second term 2, third term 3, fourth term 4, 5, 6. This goes on up to infinity. Right. Now, from this expression, from the sequence, what is first term? A is equal to 1. And common difference, D is equal to 2 minus 1, that is equal to 1. So, A is 1 and D is 1. Now, the question is to obtain the general expression for this arithmetic sequence. So, we have general expression. Right, general expression. That means we can write this is equal to nth term. That is A plus n minus 1 times D. Now, substitute for value. So, A and D, we get A is equal to 1. 1 plus n minus 1. Common difference again 1. Okay. Now simplify this equation. 1 plus n minus 1. This plus 1 and minus 1 is cancelled. So this is equal to n. Right. So general expression for the natural numbers. That is, so we can write general expression for this arithmetic sequence. That is equal to n. This is the general expression. Now we can obtain this arithmetic sequence from this general expression, right? So for that purpose, we can obtain T1, that is equal to n1. T2 is equal to n is equal to 2. T3 is equal to 3. T4, that is equal to 4, and so on, right? So the general expression for natural numbers, right, is n, right? Now you can consider another sequence. Then we have to develop the general term, right? For example, they are giving a sequence 1 by 2. Second term is 3 by 2. Third term is 5 by 2. This is 7 by 2. And goes on. This is the arithmetic sequence. Here, what is first term? We have first term A is equal to 1 by 2. Right. Now, what is the common difference? D is equal to the difference of any two consecutive terms. For T2 minus T1, we can obtain 3 by 2 minus 1 by 2. That is equal to 3 minus 1 by 2. Or 2 by 2, numerically equal to 1. Right. Now, obtain the general expression for this arithmetic sequence. Okay, so general expression, we can write Tn, that is nth term, that is equal to A plus n minus 1 times D. Now substitute for A and D, we get A is 1 by 2, right? 1 by 2 plus n minus 1 multiplied by 1, right? Now simplify this expression, we will get 1 by 2 plus n minus 1, that is equal to, see, by taking the LCM, we can simplify this equation, right? So this becomes 1 plus 2n minus 2 divided by 2, or is equal to 2n 1 minus 2. So minus 2n minus 1 divided by 2. So that is a general expression for this arithmetic sequence. So we can say nth term, that is equal to 2n minus 1 by 2. This is the general expression, right? Now we can obtain this sequence from this general expression. For first term, what do we have to do? We can put T1. T1 is equal to 2 into n is equal to 1. 1 minus 1 by 2. That is equal to 2 minus 1 by 2. That is equal to 1 by 2. we got the first term, right? Now we can obtain the second term. T2 is equal to 2 into, instead of n, put 2, minus 1 by 2. This is equal to 4 minus 1 by 2. That is equal to 3 by 2. So we got the second term. Similarly, we can obtain third term, fourth term, etc. Right. So in generally, we told, suppose I am writing a general expression. For example, 2n. Okay, I will write a general expression. Okay, let general expression, the n term is given by 2n plus 3 by 6, right? So this will be the general expression. Now check whether this expression represents an arithmetic sequence, right? Check whether this represents an arithmetic sequence, right? Arithmetic sequence. This is a question, right? Since we already told our general expression become in this time some constant times a is a constant, that's a real number, plus some b is another constant that is multiplied by n. If the general expression is in this form, that will definitely represents an arithmetic sequence. Here 2n plus 3 by 6. We can write this is equal to 2n by 6 plus 3 by 6. So that is numerically equal to n by 3 plus 1 by 2, right? N by 3 plus 1 by 2. This is similar to this expression. Here a is equal to 1 by 2 and b is equal to 1 by 3. So this tn we can write first writing 1 by 2. So 1 by 2 plus 1 by 3 times n. Okay, so this is, both these equations are similar, right? This equation is similar to this equation. From here, we can determine the value of any terms. So we already told the b is same as that of the common difference, right? Common difference. That is equal to d. So by looking itself, we can determine the value of common difference. Common difference for this problem, that is d. d is equal to a common difference, that is given as 1 by 3, right? Okay, and since both these expressions are similar, this will definitely represent an arithmetic sequence. Now we can evaluate first type t1. T1 is equal to, I am just putting n is equal to 1, right? N is equal to 1 in this expression, or we can directly obtain from here. So 1 by 2 plus 1 by 3 into 1, that is equal to 1 by 2 plus 1 by 3. This is the first term. By simplifying, by taking LCM, we get 3 plus 2 by 6. That is equal to 5 by 6. This is the first term. So putting n is equal to 1, 2 into 1. 2 into 1, 2 plus 3 by 6. That is equal to 5 by 6. Now obtain second term. T2 is equal to 1 by 2 plus 1 by 3 multiplied by 2. Right. So we can write this 1 plus 1 by 2 plus 2 by 3. Now simplify by taking the LCM. We will get 3 plus 4 by 6. That is equal to 7 divided by 6. So our second term, T2 is equal to 7 by 6. Similarly, that is T3. T3 is equal to 1 by 2 plus 1 by 3 into 3, right? So simplifying this, that is equal to 1 by 2 plus 1, right? Or we can say this is equal to 1 by 2, right? You can simplify by taking LCM. So 3 plus 6 by 6. This is equal to 9 by 6, right? Okay. So this is the different terms. So we evaluated 3 terms of this sequence, right? Okay. So now I am writing the sequence. Okay, so our sequence is, first term is 5 by 6, second term is 7 by 6. Third term is 9 by 6. Next term will be 11 by 6 and so on. This is an arithmetic sequence. What is the first term? A is equal to 5 by 6. Right, that is the first term. Then common difference D is equal to 7 by 6 minus 5 by 6. The difference of these two consecutive terms. That is equal to 2 by 6. That is equal to 1 by 3. Right, 1 by 3. So we are got the common difference D is equal to 1 by 3 and first term is equal to 5 by 6. Right. Okay. Now, suppose we want to prove whether the sequence is an AP. Okay, the sequence is an AP. For example, I'm writing the nth term. Nth term. Right. We can write nth term. Tn is equal to a plus n minus 1 d. Right. Or I told this is equal to a real number a plus n times d minus d. And we know that a and d are real numbers. So difference of two real numbers is always a real number. So this is numerically equal to a times nd. And here n is also a real number. So I am using another alphabet so as to denote that d. So we a plus n times d. This is a general expression for an AP. Okay. General expression for an arithmetic sequence or arithmetic progression. Right. And by simply looking itself, we know A and B belongs to real number. R stands for real number, right? Belongs to real number. Okay. And N is an integer. Since position is an integer. Okay. That means N is position. So it is an integer, right? Okay. Now, what is, and we already told what is B? B is equal to common difference. B same as that of the D. That is our common difference. Okay, right. Now, what is the term just before nth term? Just before nth term means n minus 1 term, right? So we have first term, so various position, right? Position 1, 2, 3, up to goes on n. Okay. I will write it. Okay. So for an arithmetic sequence, we have various positions, right? Position 1, 2, 3. This goes on up to n. So just before n, we have n minus 1, right? Just before n, we have n minus 1 time. After n, we have n plus 1 time, and so on, right? That continues n plus 1 times. Okay. Third position, fourth position, then nth position, n plus 1 position, n plus 2 positions. That will go on up to infinity. So just before n, we have n minus 1 position, right? So this is an arithmetic, and we will write the terms. Okay. This we have first term, second term, third term, fourth term, denoted by T4. This is n minus 1 term, that is indicated by Tn minus 1. This is our nth term, Tn. This is our n plus 1 term, etc. And this is only a position for I am writing an arithmetic sequence, right? Arithmetic sequence that 2, 4, 6, 8. This goes on, right? So first term, there's a number in the first position, that's T1. 4 is a number in the second position, that is T2. 6 is a number in the third position, that is T3. And 8 is a number in the fourth position, that is the fourth term, and so on. So we already wrote the nth term. Nth term where AP will be in the form A plus n times b. So we can write n minus 1 term. That is equal to A plus n minus 1 times b. Right. And we know that common difference is the difference of two consecutive terms. So either T, we can write common difference T. That is equal to T2 minus T1. That is same as T3 minus T2. That is same as T4 minus T3. Right. This goes on, and we can say this is same as Tn minus Tn minus 1. Okay, so this will goes on, and we can say D is equal to nth term minus the term just before the nth term. Just before the nth term, we have n minus 1. So T n minus 1. Or this is same as T n plus 1th term minus T nth term. This is equal to T n plus 2 term minus T n plus 1. Right. Okay. So here the difference of these two will give the common difference. That is, we can write the common difference B is equal to Tn minus Tn minus 1. Okay. Now simplify this. We will get this is equal to Tn means A plus Nb. Right. Minus A plus n minus 1 times b. Right, now simplify this. This plus a and minus a gets cancelled. So I will write this here. This is equal to n times b minus here nb minus b. Right. This nb and minus nb get cancelled. Minus of minus b. That is equal to b is equal to a constant. A constant, that's a real number. So this will represent an arithmetic sequence. So to check whether a sequence is arithmetic, what we have to do? We first find the general expression. That is the expression for nth term. Then find the expression for n minus 1 term. Just replace n by n minus 1 and obtain the difference of nth term and n minus 1 term. If it is a constant, if it is a real number, then that indicates that sequence will represent an AP. Right. Now, suppose I'm writing another sequence. For example, 5, 25, 125, 625, and so on. Right. Check whether it is an AP. Check whether the sequence I wrote above, check whether it is an arithmetic progression or arithmetic sequence. We told if it is an arithmetic sequence, then the general term will be in the form a constant plus n times another constant. If this we can obtain the expression in this way, then that will be definitely an arithmetic sequence, right? So what is actually this is a sequence. We can obtain some rules so as to develop second term, third term, fourth term from the first term, right? Suppose this is 5, right? 5. 25 means 5 square. 125 means 5 cube. 625 means 5 raised to 4. And next term becomes 5 raised to 5, right? Okay, so first is 5. Second term is obtained by multiplying 5 2 times. Third term is obtained by multiplying 5 3 times, and fourth time 5. Okay, now look at this sequence. Look at this sequence. Is it AP? This is not an AP, right? Since there is no common difference. So suppose T2 minus T1. What is T2 minus T1? 5 square. 25 minus 5. That is equal to 20, right? Now what is T3 minus T2? T3 minus T2 is equal to 125 minus 25. Second time is 25, right? This is equal to 100. Okay. Since the difference of T2 minus T1 is 20 and T3 and T2 is 100. These are not equal, right? So this is not an AP. Okay. Since there is no common difference. So just look at the sequence. So we have first term A is equal to, or we can write term 1. That is equal to 5. Term 2. That is equal to 5 into 5. Term 3, that is equal to 5 into 5 into 5. And T4, that is equal to 5 into 5 into 5 into 5. Okay, so T1 is 5 multiplied 1 time. T2 means 5 multiplied 2 times. T3 means 5 multiplied 3 times. T4 means 5 multiplied 4 times. So you can write Tn. Tn means n multiplying how 5 multiplying how many times? 5 multiplying n times. So we can write t n nth term, that is equal to 5 into 5 into 5 up to 5. How many 5s? We have n times 5. 5 is multiplying n times. Or we can write nth term Tn is equal to 5 raised to n. 5 raised to n. Right, 5 raised to n. So from this general expression, what is T1? T1 is equal to 5 raised to 1, that is equal to 5. T2 is equal to 5 raised to 2, that is equal to 25. T3 is equal to 5 raised to 3, that is equal to 125. And so on. Right. Now, we want to check whether it is an AP. So what we have to do? We simply write n minus 1 term also. So we have nth term, that is equal to 5 raised to n. Okay. And n minus 1 term, that becomes 5 raised to n minus 1. Okay. So Tn minus Tn minus 1, that is equal to the difference of this. 5 raised to n minus 5 raised to n minus 1. Okay. So simplify this. We can take 5 raised to n is common. So 5 raised to n multiplied by 1 minus 5 raised to minus 1. Right. Okay. So this is equal to by simplifying, I'm writing the remaining here. So 5 raised to n multiplied by 1 minus 5 raised to minus 1, we can write as 1 by 5. So this is equal to 5 raised to n multiplied by, take the LCM and simplify, 5 minus 1 by 5. Right. So this is equal to 5 raised to n multiplied by 4 by 5. Okay. So this is equal to 5 raised to n and 5 is cut one time. So this becomes 4 raised to 4 into 5 raised to n minus 1. Okay. So this is a difference of nth term and n minus 1 term. So in the difference is a function of n. Function of n. So it is not an AP. If it is an AP or arithmetic sequence, then what happens? The difference of nth term and n minus 1 term, that is a constant, that is not a variable. Here, the difference of nth term and n minus 1th term seems to be 4 times 5 raised to n minus 1. That is a function of n. So that is not an arithmetic sequence, right? Okay. Now, based on this fact, we can do some problem. Okay. Now, suppose in a problem, we have an arithmetic sequence. Okay, arithmetic sequence is given. Whose sixth term is T6 is given as 6 and 12th term is given as 18. Right. So 6th term and 12th term is given. Now the question is find the corresponding arithmetic series. Right. This is our question. So 6th term is given, 12th term is also given. We want to determine the arithmetic sequence. So we know its general expression. The nth term means a plus n minus 1 times d. Right. Here a is not given and d is also not given. But 2 terms are given. Right. T6. So we can write what is our T6? T6 can be write as a plus how many d? N minus 1. So 6 minus 1. That is 5. A plus 5d. That is given. This is given is equal to 6. And T12. We know T12. That is equal to a plus how many times d? 11 times d. That is also given as 18. Right. So we have equation number 1 and equation number 2. So 2 equations and 2 unknowns. So solve this. We will get the value of a and d. Right. So just subtract these 2. So you get a and it cancels 0 plus 5 minus 11d. That becomes minus 60. That is 6 minus 80. 6 minus what? The operation I am doing is 1 minus, this equation 1 minus equation 2, right? By solving this equation, first equation minus second equation, so and get cancelled. 5 minus 11, that becomes minus 60. Here it becomes minus 12. So what's the value of d? D is equal to minus 12 divided by minus 6. That is equal to plus 2. So we got the common difference. So by substituting the value of 2, either in any equation, either you can put in equation 1 or in equation 2, you will get the value of it. Now, I am putting the value of d in equation 1. Now, we can write the step as substitute. So this operation is subtraction, right? Subtraction. Now, substitute or put, right? Substitute d is equal to 2 in any of the equation, but we can substitute in equation 1, right? So our equation 1 is a plus 5 times d, these two, that is given as 6. So a plus 10 is equal to 6. From here, we get a is equal to 6 minus 10, that is equal to minus 4, right? So we got a and d. Now we can obtain the arithmetic sequence, right? Okay. So what is the arithmetic sequence? Arithmetic sequence is first term. What is the first term? First term is a, right? So for the sequence, we got a is equal to minus 4 and d is equal. A is equal to minus 4 and d is given as 2, right? So we got our first term, that is t1. t1 is equal to minus 4. What is t2? t2 is equal to a plus d. Here a is equal to minus 4 plus d, that is equal to minus 2, right? And t3 is equal to a. What is a? A is minus 4 plus 2 times d, that is equal to minus 4. I'm writing here a, right? A plus 2. So a means minus 4 plus 2 times 2, that is equal to minus 4 plus 2 into 2, 4. So minus 4 plus 4, that becomes 0, right? Now what is t4? t4 is equal to a plus 3d, that is equal to minus 4 plus 3 times 2, or minus 4 plus 6, that is equal to 2, right? So we can write the sequence. First time is minus 4, second time is minus 2, third time is 0, 2, 4. This goes on, right? So this is the required arithmetic sequence. Now, what is the general term? So this is our required arithmetic sequence, right? Okay. Now, what is the general expression for the sequence? So we can develop the general expression by making use of nth term. So general expression Tn, that is given as a plus n minus 1 times d. We got a is equal to minus 4 plus n minus 1 multiplied by common difference 2. So this is equal to minus 4 plus 2 times n minus 2. Or we can simplify this, 2n minus 4 minus 2, that becomes minus 6. So this is our general expression, 2n minus 6. This is similar to that of a plus NB, right? A plus NB. This is a general expression. And from here, we know B is our common difference, CD, that is the common difference. So what is the value of B here? The value of B here is 2, right? 2. So 2 is the common difference. From the general expression, we can also obtain this sequence, right? So what is T1? T1 is equal to 2 into 1 minus 6, that is equal to 2 minus 6, that is equal to minus 4. Now, what is T2? T2 is equal to 2 into 2 minus 6, that is equal to 4 minus 6, that numerically equal to minus 2. and T3 is equal to 2 into 3 minus 6. That is equal to 6 minus 6. That is equal to 0. So we got minus 4, minus 2, 0, and so on. So what is the 100th term? So once you develop the general expression, then we can obtain any terms by making use of the concept of general term. So we can, I want to evaluate 100th term. So what we have to do? We just put the n is equal to 100 in the general expression. So we will get 2 into 100 minus 6, right? Or 200 minus 6. That is equal to 194. So this is a value of 100th term, right? So we can find any terms by making use of this. Okay. Now we can do one more problem from this topic, right? From the topic of general expression, right? So my question is, I have an arithmetic sequence. It is constructed an arithmetic sequence. Sum of T6. No, T6 we already used, right? Suppose T10. 10 is equal to minus 20. And T20, that is given as minus 60. Right. So 10th term and 20th term of an arithmetic sequence is given. My question is to find 99th term. 99th term. Right. What is 99th term? 99th term means the term in the 99th position. That is denoted by T99. This is our question. So we want to determine the value of T99. Okay, this is very simple, right? So we can write 10th term. This is equal to A plus 9D. And 20th term, that is equal to A plus 19D. So the A plus 9D. What's the value of A plus 9D? We got A plus 9D. That is equal to minus 20. And A plus 19D. That is given as minus 60, right? Now, let us put this is equation number 1 and equation number 2. And the operation is equation number 1 minus equation 2. 1 minus 2 implies A and A get cancelled. A minus 0 plus 9D minus 19D. That is equal to minus 10D. Here minus 20 minus 60. That becomes plus 40. Or D is equal to 40 divided by minus 10. That is equal to minus 4. So our common difference is minus 4. Now we need to find the value of A. That can be obtained by substituting the value of D in either of the equation. Now we can write substitute the value of D in equation 1. All right. Now put D is equal to minus 4 in equation 1. What's the need of putting D is equal to minus 4? We want to determine the value of A. So we can write A plus how many D? 9D. That is equal to minus 20. So A plus 9 into minus 4. That is equal to minus 20, right? Or A minus 36 is equal to 9 into 4. That is 36 minus 4. So minus 36, that is equal to minus 20. Or we can obtain A is equal to minus 20 plus 36. That is equal to 16. Right. Now we got the value of A and value of B. Now we can develop the general expression. Right. General expression. Then we want to find the 99th term. That is our question. Right. Okay. So we got the value of A. A is equal to 16. Right. D is equal to minus 4. Okay. Now nth term Tn, that is equal to A plus n minus 1 times common difference. So 16 plus n minus 1 multiplied by minus 4. Right. Now simplify this equation. We get this is equal to 16 minus 4n plus 4 or is equal to 16 plus 4, 20 minus 4. This is the general expression, 20 minus 4. Now, suppose we want to check whether this is right or not. Right. For that purpose, we just find T1. T1 is equal to 20 minus 4 into n is 1. That is equal to 16. So we got the first term as 16. Right. Now, what is the sixth term is given? Sixth term is given as T6. That is equal to 20 minus 4 into 6. What is 20 minus 24? 20 minus 4. Okay. 4 into 6. Okay. This is the sixth term is 20 minus 4 into 6. 20 minus 24. That is equal to minus 4. Right. And what is 10th term? 10th term. That is equal to 20 minus 4 into 10. That is equal to 20 minus 40. That is equal to minus 20. This is already given. So this is right. And term is right. Now, what is question? Our question is to find the 99th term, right? So we can write 99th term, that is T99, that is equal to 20 minus 4 into 99, or 20 minus 4 into 99 means 396, right? 396. So this is equal to minus 376. This is the 99th term, right? Now, in the next session, we will discuss how to find the arithmetic sequence when some terms is given and product of is given. Suppose we have given sum of 3 terms and its product is given, or sum of 5 terms, or sum of 7 terms. So sum of 3 terms means 3 means odd number, 5 means odd number, 7 means odd number, right? So in the question, they may give sum of 3 terms and its product is this much. Find the arithmetic sequence, right? Or there may be a problem in such a way that we need to find the arithmetic sequence when sum of 4 terms, 4 means an even number, sum of 4 terms and whose product is given, right? Or sum of 6 terms, 6 means an even number. So there may be questions in which some terms will be given, some of 4 consecutive terms, or some of 6 consecutive terms, or some of 8 consecutive terms. Then their product will also be given. Then we want to find the arithmetic sequence. That will be discussed in the next class. Okay, thank you. Bye.